Okay, I'm going to spare you of something in the first part of 5.2. I just don't think it's necessary. So we're going to move right into what's called definite integrals and signed area. You guys already know a lot of, you know what an indefinite integral is, right? Yep. Okay, so that's going to aid you immensely today. What we got to address first, okay, signed area. So integrals, we've been doing integrals that calculate the area under a curve, correct? Okay, so what we haven't discussed is what happens if you go underneath the x-axis. Okay, so this area is positive. So let's say this area is 10. Okay, and let's say this area is 6. Okay, the integral of that is not 16. Okay, it's not the, okay, it's 4. Because this is a negative area because it's below the x-axis. All right, so you have to be careful sometimes on some problems, and I'll, of course, help you and detail those out for you, but you have to be careful knowing sometimes you have to split those up. Okay, so signed area. Let me give you an example here. Okay, this is a definite integral. Right, you see the numbers now? Those are basically what we would say is the integral from 0 to 5 of 3 minus x dx. Okay, that's what I would say. So with indefinite integrals, we were not given boundaries. So we didn't know where to stop. Okay. Those are x values, they're boundaries from 0 to 5. So we actually have a shape. Okay. We'll go ahead and graph this so you see it. Okay, there's the graph of that function, 3 minus x. Okay, notice 0 to 5 are our limits. So we're going from 0 to 5, right? So we're taking, what is the area of that? That's what we're calculating, okay? As triangles, we can do this very easily, geometrically, right? So the base of this is 3, the height's 3. Yeah, it is going to be minus. And the base 2 by 2. There are a couple ways to represent that. Some people just put a minus sign because it is below the x-axis. That's fine. Sometimes I'll put just that the area is signed negative. It doesn't matter, honestly. What you end up with is 5/2 as your area. Okay. Because you are subtracting that little bit out. Okay. Now, that was geometrically. We can do it algebraically or with calculus. Okay. What's the integral of 3 minus x?
3x minus 1.
And then always put that there. Okay, so this is the integral. Definite integrals get rid of c. That's the beauty of definite integrals. We've defined it on a certain interval so the c can be dropped. Okay. Right. Okay. It basically subtracts out. It doesn't matter anymore. Okay, so we're evaluating this function from 0 to 5, which means plug 5 in. Subtract, plug 0 in. Okay, it's always minus.
Wait, what?
Thanks for that.
Oh, okay. How in the world did you go from the top one to that whole set of plugins and stuff?
To here?
Yeah.
Do you understand how I got here to here?
What?
Do you understand step 1 to 2?
Yep.
Okay. All I did, I took 5 and I plugged it in for x.
Okay, then why are you minusing that?
Now, and then subtract this plugged in. Okay, if that's a number and it doesn't give us 0, like graphically, you know, if I'm going from, let's say, 1 to 3, and I want this area, when I subtract this out, I am just taking this out of the mix. Okay, so I'm not counting it because I don't want it counted, right? That's why I subtract it out. Okay. So what we end up with here is 5/2, same answer, bam. Okay. So use all of the same rules we've learned for indefinite integrals, you know, the power rule, etc. There's a couple more things to show you.
I grew up with them. I didn't know they were married. Yeah, they're in my church and she used to babysit when I was little.
Let's just totally different problem we're doing here.
Okay, this is just what we call a definition. Okay, so if we have an integral that's, the bottom one, say it's 5 to 2. I can flip it and just take the negative and go from 2 to 5. It's the same thing. Okay. It proves useful once in a while.
Game changer.
So if I had something like this, it's easier if the bigger number's on top. Those are the same thing. All right. It gives you the same answer. Do you want me to finish this problem? Yeah, it's just a setup thing. If you can do the integral, your money. Okay. Here's a theorem. Additivity or adjacent integrals. This one we do need and we will use it. Okay, so we have 3 numbers. A is less than or equal to B, less than or equal to C. If we have the integral from A to C, and we need to split it, and we will at times, the assigned area is a good example of sometimes we have to split it. We can do the integral from A to B plus the integral from B to C.
Oh.
Yeah, boom. We just did that.
What is that on the bottom? Let's see. Or
A to B. So this is A to C, A to B, B to C. Okay, so here's a picture geometrically. Here's the area from A to C, right? There's the area from A to C. Okay, we can do A to B plus B to C. Does that make sense? I wish.
is B the point of involvement?
That's not a, no, that's a derivative term. We don't use it with integrals. B is just a partition. It's just a different partition. So we'll run into some situations where you need to use that, and I'll tell you when. But do you have any questions? Okay, so basic definite integrals. Here's your
work. We'll work on it tomorrow in class.
Work on it tomorrow in class.
Yeah, I'll show you a couple things tomorrow. But you'll have most of the hour to work. We're not going to take notes tomorrow, thankfully.
I really do.
Outside. I did sucks to suck, guys.
Oh.
Yeah, you'd know. Yeah, it's on. Burn! Come on, hey, we gotta rise that, everybody. Made them laugh.